In this video, we're going to discuss energy. So, to start with, what is energy? Like we hear the term occasionally, but how do we define energy, especially here for chemistry? Energy is the ability to do things. If you don't have energy, you can't accomplish something. If you don't have gas, your car won't move. If you don't have enough speed, you can't coast up that hill, and you're going to have to pedal, and you're going to have to burn your own energy. How does this translate into things, though? How do we discuss it? Well, humans are fairly familiar with two types that we're going to talk about today. Pick up a pen or something and lightly toss it in the air. It goes a little bit up and comes back down. Do it again, but put a little more force. It might go a little bit higher. Now you get near the ceiling before it comes back down. You put more effort in, and it was able to move farther. Movement is a type of kinetic energy. Because we are creatures that move around, we are actually fairly familiar with this. A baseball thrown at low speed hits you, doesn't really hurt. A baseball thrown at high speed at you is going to hurt quite a bit. Size of an object and speed relate to its kinetic energy. If you have a car and it's moving at slow speed and hits you, that's going to hurt, right? Despite the baseball and the car both being slow, the bigger thing still hurt, while the smaller one didn't really. But a small one moving fast can still hurt. We are fairly comfortable with the concept of kinetic energy just from our daily lives. Other things, if you put your hands together and you rub, they warm up. You can make your hand get hotter through friction. This is thermal energy. It is heat energy. Now, if you put your hands beside each other, not touching, and you do the same back and forth motion, they don't get hot. You had to have them touching. You needed that friction. You can convert energy. So energy can convert types. There's different ways that allow it. Friction is one where kinetic can become thermal. There's other types, but energy can never be created or destroyed. It can only convert from one form to another. Well, if you ever held two magnets and start them a couple inches apart and you start bringing them together, you get them a little closer, nothing's really happening, and then all of a sudden, bam, they pull together and slap together. They weren't doing anything, and then suddenly they moved. Something became kinetic, but you can't create energy. So they had to have another form of energy that became kinetic energy. This is potential. Potential is waiting to happen. Try this. If you hold a pen above a table, say a foot, and just hold it there, it's not moving. Nothing is happening. But if you let that pen go, suddenly it falls and it hits the table. Out of nowhere, it suddenly gained kinetic energy. The idea was gravity was always pulling the pen. It just wasn't able to fall because you were holding it. As soon as you stopped holding it, suddenly it could fall the distance down to the table. But now that it's on the table, use your Jedi mind powers all you want, that pen isn't going back up to your hand on its own. It's spent the energy. It has no ability to go back up against gravity. Now you could grab the pen and lift it up, but that's using your muscles and using your glycolic energy and other things for metabolism to lift the pen. You are putting energy back into it by burning your own muscle energy, your own kinetic energy, to lift it. So the question is, where did the energy originally come from to make it move down while it lacked it anymore to move up? That is what potential energy is. It is energy waiting to be released. If you think about a stick of dynamite, if you're holding a stick of dynamite at room temp, it feels like room temp. Like any object at room temperature just kind of feels like any other object at room temperature. Now you know that dynamite could explode and release a huge amount of energy, big explosion. But it's not hot to the touch when it's just sitting there. So where is that energy coming from? It's not thermal, and it's not moving, so it's not kinetic. Dynamite has a lot of potential energy waiting to be converted to kinetic and thermal. And this is what's super important for chemistry. Potential energy, well, chemical bonds contain potential energy. What's going on with that? Think about how a bond works. I've got, let's say, some hydrogens here. And they've got their orbitals overlapping, so there's some electrons. Those positives are attracted to those negatives. So it's a simplified covalent bond. Well, like magnets, they're attracted. They pull in towards one another. Now, if you've ever held magnets, if they're a little ways away, they don't really seem to pull. Get them slightly closer, you maybe feel it. Get them slightly closer, and suddenly you feel it a lot. The distance between charges has an exponential effect on how strongly they attract. So very slight differences in distance can change dramatically how strongly they're attracted to one another. Now, if you ever let magnets get near each other, you have to put some effort in to pull them apart. Our hydrogen molecule here, it's actually got a balance. If the nuclei get too close, well, the electrons start kind of getting out of position. And if they get much too close, then the electrons are actually so far away that the nuclei are repelling each other instead of being attracted to the electrons. There's an ideal distance. If you have energy and you have distance. So here is the fully separated atoms. I've got two atoms and they have nothing to do with each other. Well, as they get closer, they actually start to drop in energy. The closer they get, the lower the energy gets. There is some ideal distance, and then if they start getting too close, that energy skyrockets back up real fast. And so there's an ideal distance for my atoms to be from each other to avoid those nuclei plus charges repelling. Different atoms are going to have different ideal distances, which means they have different attractions. The closer you can get your opposite charges, remember, the more strongly they're attracted. How chemical bonds work is that if I have, say, methane, carbon and hydrogen are so well attracted to each other, and if I have oxygens are so well attracted to each other. But when I make carbon dioxide and I make water, OH bonds are stronger than CH bonds, and OC bonds are stronger than OO bonds. I can just get closer with my hydrogens and my oxygens and my carbon and my oxygen than I can between my two oxygens or a carbon and a hydrogen. The net result is I have to put a little work into break my bonds of my starting materials, but I get back better attraction in my products. We tend to draw this as kind of energy on the side. We say, hey, these starting molecules, my CH4 and my O2, they were higher in potential. They gave away that potential so they could pull physically in closer as they became products. And so my CO2 and my water actually gave away potential energy as they fell closer towards each other. And so think about the magnets again. If you're holding them very far away, right, and they have the maximum distance they could pull towards each other. So if you hold them a foot apart and you let them go and they slowly pull together and then speed up, they have all the movement of that full foot. But if you hold them only an inch or two away and you let go, they'll still be pulled together, but they have less distance to travel. Go back to the pen falling on your table. If you hold it only a couple inches, it falls and hits lightly. If you hold it above your head and drop it, it'll make a bigger noise when it hits. It built up more energy by being able to fall farther. Our weaker CH and OO bonds have more potential. They could get closer to things. And so once they reorganize, they got closer, and so they were at lower potential energy. Well, the rest of that energy has to go somewhere. And usually what happens is chemical bonds release it as heat. And so radiated out into the world was some heat, which is what happens when you burn natural gas. Methane is natural gas on your stove. You light it on fire to make carbon dioxide and water, and it gives off heat. This is how it's giving off that heat. It's actually the difference in the potential energy being converted to thermal. So in the same way your kinetic rubbing your hands together used friction to become thermal energy, reorganizing atomic bonds is able to convert potential into thermal energy. So this is kind of the concept of energy as it relates to chemistry. We have kinetic, which we don't use too much in chemistry. Physics does a lot more of that. We have thermal and we have potential. And we will talk a great deal about thermal and potential. But here's where it's coming from. Chemical bonds, those attractions between charges, as we reorganize atoms, they can get closer or further away, and that changes their potential. The closer they can get, the less potential they have, the more they must have given away to the rest of the universe. The further apart they are, the more potential they have, and so they must have stored it from the rest of the universe, waiting to release it.